Okay, section 7.1 and 7.2 gives you an exponential functions glimpse. Gives you an idea of what exponential functions are, what the characteristics of them are, how to graph them, how to solve them, and the main two applications here that you see in the real world are compound interest and continuous compounding. Good morning. You see compound interest and continuous compounding. So whenever you're talking about money, say you're investing money, and you want to figure out how often it's compounded. If it's compounded monthly, then we use compound interest formula. If we say that you invest a certain amount of money and it's continuously compounded, then there's a formula that we use for that. These two will be the important applications that you learn in section 7.1 and 7.2. So make sure you are aware of that. You will see applications of those. Okay, so let's define an exponential function. So let A be a fixed positive real number that's not equal to 1. The exponential function with base A is the function f of x equals a raised to the x. It kind of looks like a power function, but the difference between a power function and an exponential function is that the exponential functions have a base A, which is really a number not equal to 1, and the exponent is a variable x. Okay? Now, a power function, just so you remember, a power function looks like x to the n. F of x equals x to the n. So that's important to remember that they are very different functions. Okay? Now, properties and characteristics of exponential functions. Given a positive real number a that's not equal to 1, the function f of x equals a to the x. We're talking about properties and characteristics of this exponential function. Okay? Is a decreasing function. The exponential function is a decreasing function if a is between 0 and 1, that's important. If a is between 0 and 1, such that as x approaches infinity, f of x approaches 0. And as x approaches negative infinity, f of x approaches infinity. We'll see some graphs in a minute, okay? We'll see some graphs in a minute. I have them on the next page. Would you like me to go back and forth between the example and the definition? Good morning. Good morning. Would you like me to go back and forth? Okay, so again, an exponential function, f of x equals a to the x, is a decreasing function if a is between what and what? 0 and 1. Good. So an example, if you have a is 1/2 raised to the x, then it's going to be decreasing. Okay, so let's look at an example because you asked me to toggle back. So the next property of an exponential function, given a positive real number a not equal to 1, the exponential function f of x equals a to the x is an increasing function. If a is greater than 1, such that as x approaches negative infinity, f of x approaches 0, and as x approaches infinity, f of x approaches infinity. Okay? So note, in cases 1 and 2, the point 0, 1 is on the graph of f, as we are about to see for an example of an increasing function. We saw that the point 0, 1 was on the graph of a decreasing function, and that gave us our what? Excellent. That gave us our y-intercept. Okay? So notice that 0, 1 is on the graph of f, whether it's decreasing or increasing. Okay? Note that the domain of f is the set of all real numbers, and the range of f is 0 to infinity. So let's look at our graph to confirm forth. So an example of a decreasing exponential function, we're going to sketch the graph of example 1, part B. We have f of x equals 1/5 raised to the x. Now, there are a few ways that you can graph this function, sketch the graph. Remember, you have your graphing calculators, that's always an option. You have Desmos, that's an option. But if you want to do it by hand and rely on that, then you go back to your XY chart. So choose X values. You have -1, 0, and 1. It'll give you an idea of what's happening on the left and right side. So let's substitute these values in for X here. Okay, so to find out what the corresponding Y values are, good morning. To find out what the corresponding Y values are, we would have 1/5 raised to the what power? -1, very good. And so 1/5 raised to the -1, do you remember the rule whenever we raise a number to the -1, what happens to it? What happens to the number? Do you remember?
I want to say cancel out, but or no.
No, it doesn't cancel out. I'm listening. It doesn't cancel out. No, because what a square root indicates, so if you have the square root of x, that's the same thing as x to the 1/2. That's an understood 1. This index is 2. But whenever you have a negative exponent, what do you do with the number? Take the reciprocal. Very good. You take the reciprocal. That's what you do. So if you have x to the -1, for example, that's equal to 1 over x. Very good. If you have x to the -n, that's equal to 1 over what?
Whatever it is. Oh.
1 over what? To the what? Nth power. Good. So that's a quick reminder. So whenever you're taking the reciprocal of 1/5, what is that? 5. Good. So if you want to write steps in, it's 1 over 1/5, which is the same thing as 5. Very good. So one point you can plot, tell me the corresponding ordered pair. -1, comma 5. Good. So -1, 2, 3, 4, 5. -1, comma 5. So it's this point. That's one point. Now, whenever x is 0, we have 1/5 raised to the 0. What is that going to be?
0.
Whoa, it's gonna be 1, right? Why?
Because when you have 0 as an exponent, that equals 1.
When you have 0 as an exponent, then your value is equal to, then your calculation is equal to 1 as long as this number inside is not 0. That's the only exception. So whenever you have something raised to the 0, it's equal to 1, provided that what's on the inside is not 0. What's the corresponding order pair? 0, comma 1. Good. 0, comma 1. So it goes through this point right here. That's also your y-intercept, right?
Yes.
That's also your y-intercept. You can identify that. Okay. Now, when x is 1, you have 1/5 raised to the first power. What's that? 1/5. Good. And so what's the corresponding ordered pair?
1,
Good, both of you. 1, comma, so we go to x equals 1, and then you have 1/5. It's tiny. So let's exaggerate a little bit. So that's 1. That's 1/5, about there. So you have 1, comma 1/5. And so notice that this graph, once you connect everything, we can connect it a little better, right? Notice that that's the graph. And notice that it's falling from left to right. So it's decreasing. It's decreasing. So if your base, A, for an exponential function is between 0 and 1, so notice that A This is just extra, not needed to write. A is equal to 1/5. 1/5 is between 0 and 1. So that means our function is going to be decreasing. Very good. That's an example. What questions do you have? Okay, so you have an example of a decreasing function. Okay, so now let's go back to our definition. Are we okay here? Or do you need a minute? Okay, taking a picture? Let me know when you're done.
I'm good.
Okay, what we just said. Notice that the range you get from your y values, remember? So your range goes from 0 to infinity, not including 0 because the graph never touches 0. So the range is 0 to infinity. And our domain, which is the set of what values? It's the set of all real numbers, yes. But, good morning. But our domain is given by what values? Your x values, good. So you can either write all real numbers or an interval notation, what is it? What goes around then? Negative infinity, infinity. Brackets?
No,
Parentheses? Yes, good. Very good. So we have a decreasing function. We have a decreasing exponential function when a is between what and what?
0 and 1.
0 and 1. Good. We have an increasing exponential function when a is what? Greater than 1. Good. So let's look at an example where we have an increasing function. We want to sketch the graph of f of x equals 5 to the x. Okay? Now, notice that I chose -1, 0, and 1 for x. That's what I tend to choose all the time to get an idea of what the graph looks at to the left and right of 0, of the origin. So, we need to determine what f of x is. So, what do I write here? When x is -1, what do I write for f of x? Good. 5 to the negative first power. And our rule tells us this is going to be what? Excellent. That's going to be 1/5. Very good. It's the reciprocal. So do you want to plot points as we go along?
Yes.
Okay, so give me the corresponding ordered pair.
-1.
And
1/5.
1/5. Good. So -1, and we'll say 1/5 is about there. So -1 and 1/5, that's the point. And now what do we do? Go to the next part, right? Would you like me to write down the ordered pairs as well? Okay, so does everyone have the rule reminder? Can I erase it? Hold on. Are we good? Can I erase it now?
Yeah.
Okay. Well, no. There we go. Okay, so you wanted me to go back and write in the corresponding ordered pairs, so let me write down the ordered pairs from the decreasing function. There you go. Okay, now, here, you said go to 0. So what do we write?
5.
Yes, 5 to the 0 power, and what is that going to be? 1. Good. So far we have the ordered pairs -1, 1/5, and then we have 0, 1. Notice that confirms what we already generalized, that the point 0, 1 is going to be on the graph whether it's increasing or decreasing. Okay, so we plot 0, 1. So go to x equals 0, y equals 1. Let's say it's about there. So that's a point, 0, 1. And then what do? Go to the next one, right? So x is 1, so what do we write? 5 to the first power. Good. And what is that? What's 5 to the first power? 5. Excellent. So the corresponding ordered pair is 1, 5. Good. So then we plot that. We go to x equals 1, and then we go to y equals 5, 2, 3, 4, 5. Let's say it's there. Extend our graph a little bit and say it's right here. Now, is this going to be a straight line? I see you shaking your heads no. You are correct. It's going to have the same shape as this one, but it's going to be what instead of decreasing? Increasing. Good. So it's going to look like so. It's going to look like that. Is it ever going to touch the x-axis? No. So that's what it means when we say as x approaches negative infinity, our function gets closer and closer to 0. As x approaches infinity, our function goes where? We said up, or it increases, but what do we say it goes to? Infinity, yes. Okay. Now, tell me, so in this case, we knew a was equal to what? For this 5, good, and we knew 5 was greater than 1, good. So we know this function is increasing, good. Okay, so other things you can tell me. What's the range? Good, parentheses 0, comma infinity, because we read the y values for our function from 0 to infinity. And what else can you tell me? Domain, good. And our domain is what? All real numbers, good. Or an interval notation? Good. With parentheses, very good. Okay. What questions do you have? Okay, so we know what exponential functions are. We know the shapes of their graphs. We know when they're increasing or decreasing. So a few things to note. Plugging in -1, 0, and 1 for x will give you a good idea of what the shape of your graph is. Okay, a few facts. Some things to remember, okay? 1, notice that the graph of f of x equals a to the x passes the horizontal line test, right? So if you take a horizontal line test, a horizontal line, and you drag it across this function, it only passes the function once, right? Remember, we used the horizontal line test to help us to determine whenever our function was 1 to 1. So that means exponential functions are 1 to 1. So exponential functions, that's important to note, exponential functions are 1 to 1. And what does that mean? And this is helpful whenever you are solving exponential functions algebraically. This you need to know. That means if we put 1 from words to math, that means a to the x equals a to the b implies x equals b. Whenever you have two exponential functions equal to each other and those exponential functions have the same base, what does that mean about their exponents? They equal each other. You got it, because exponential functions are 1 to 1. Do we need to say it one more time? Okay, so let's say it one more time then. When you have two exponential functions with the same base, what does that mean about their exponents? They equal each other, but they have to have the same what? Base. Okay? So if two exponential functions are equal to each other and they have the same base, then their exponents are equal. This is because exponential functions are what? 1 to 1. You got it. Okay? This is helpful because knowing exponential functions are 1 to 1 helps us solve them. Okay? So whenever we solve exponential functions, they will not always be given to you in the form of where you have them having the same base. You may have to do some work to get them to have the same base. But this is what you will ultimately use to help you solve them. What questions do you have? So far we know exponential functions. Good morning. So far we know exponential functions are decreasing when? Good, when a is between 0 and 1, and a is your what? Base, very good. We know exponential functions are increasing when what? A is greater than 1. Good. What is a point that's always on the graph? 0, 1, and that is also your what? Y-intercept. Good. So excellent. Okay. So what are 3 points, 3 x values you can always choose? Negative 1, 0, and 1 to give you a good idea of the shape of your graph. Okay. Excellent. So now it's examples, and you will see these types of problems again. Okay. So let's solve the following exponential equations. Let's solve the following exponential equations. Let's solve the following exponential equations. We have 25 to the x minus 125 equals 0. Okay? So we have 25 to the x. Let's move the 125 to negative 125 to the other side. So that means 25 to the x is going to equal what? Equal 0?
Oh, equals 125.
Good. All 3 of you. Good. So now, where do you think we go from here? Why would you square root? You're trying to get rid of this exponent? Can you get rid of this exponent that way? Whenever you take the square root, ultimately you would like this to be a what?
A number.
And specifically what if you're trying to take the square root? A 2, right? But this is an x. So our approach has to be different because this is what kind of function? It's an exponential function. When you see a number raised to a variable x, that is an exponential function. Okay? So we want to ultimately here want to create a situation where these two have the same base. Okay? How do you think we can rewrite 25 and 125 where they have the same base? Something with the 5. Why? Because they have it in common? Yes. So we can do that, right? Because 25 and 125 have 5 in common. So let's rewrite these two with a base of 5. 25 is 5 raised to the what? Second. Good. So that's 5 squared to the x, right? Are we okay? Okay. And what's 125 with a base of 5? To the third. Good. 5 to the third. Think of money. 5 times 5 is? 25 times 5 is? 125. Right? So you have 5 squared raised to the x equals 5 cubed. On the left, that's really 5 raised to the what power? Say aloud. 2x. Good. So now you have 5 to the 2x equals 5 cubed. Now what can you tell me? The bases are the same, so 2x equals 3. Good. 2x equals 3 because we know exponential functions are what?
1 to 1.
Good. Exponential. We go from that step to that last step because exponential functions are 1 to 1. So, what do we do to both sides now? Say what? I can't hear you. Divide by 2. Good. To get x equals what? X equals 3 over 2. Good. And that's your answer. Now, you can always check. You can always check. Okay, so let's check. A way you can check. Yes, you can use your calculators, but you need to know how to enter it into your calculators. And your calculator can only do what you tell it to do. Okay? So the way you check that is you put 25, or you write 25 raised to the 3/2. Right? That's the same thing as 25 to the 1/2, all of that to the 3rd. Are we okay? 25 to the 1/2 is the same thing as what? Good. The square root of 25, right? And we're doing what with that? Times 3?
I mean,
To the third power. Good. Right? What's the square root of 25? 5. Good. And what's 5 cubed?
125.
125. So is this going to be true?
Yes.
Yes, because 25 raised to the 3/2 is 125. And 125 minus 125 is 0. So yes, that checks. What questions do you have? What questions do you have? Let's try another one. Here we have 4 raised to the 3x plus 2 equals 1/4 raised to the negative 2x. Let me zoom in a little bit. That looks a little small on the screen for you. Is that better? Okay. Wake up, y'all yawning. Wake up. Y'all got to finish strong. Listen, this is the last day. You still got finals. Don't check out yet. Okay? So, you have 4 raised to the 3x plus 2 equals 1/4 raised to the negative 2x. How do we approach this problem? To what? Try to have the same base. Good. Try to have the same base. What are your thoughts on how to get there?
I think it's turn to 4 to like 1.
You said, go ahead.
I think we should try to get 1/4 to 4. I think that would be
Get 1/4 to 4. You think that would be easier
than trying to get 4 to 1.
than trying to get 4 to 1/4?
Yeah.
Okay. That's correct. So how do you get 1/4 to have a base of 4? The reciprocal? So how do we write it? 4 to the 2x? How did you get 4 to the 2x? So you are going to be correct. Does everyone see it that way though? You raising your hand, go ahead.
Can we raise the whole, both sides, raise them to the negative first?
Do you have to raise both sides though?
No, because then that will change that.
That will change the left side. You only want to rewrite the right side. So both of you are correct, okay? Both of you are absolutely correct. So we're going to write a step in between, but eventually you're going to have 4 to the 3x plus 2 equals 4 to the 2x, as Lisa told us. But Zira said that you have 4 to the 3x plus 2 equals, you're going to rewrite 1/4 as what? Hmm? 4 to the what power?
Negative first?
Yes, 4 to the negative first power. And then the negative 2x, right? Good. But then negative 1 times negative 2x is what? Positive 2x. That's why you can go from that first step to this one. But writing the step in so you can see it is helpful. What questions do you have? So just because it looked a little challenging initially, you thought it through. That's what you're going to have to do whenever you see these types of problems. You started out by thinking, I need these to have the same what? Base. I need them to have the same base. So then we need to remember the rules in order to rewrite the function. Good morning. In order to rewrite the function, right? So we rewrote 1/4 as 4 to the negative 1. Now we put ourselves in a situation where they have the same what? The same base, right? They have the same base. Good. So what does that mean?
3x plus 2 equals 2x.
Good. 3x plus 2 equals 2x. Well, how do we get from there? Why is that true?
Because they have the same base, meaning they're 121, meaning that the x was equal to each other.
Good. Exponential functions are 1 to 1, which means if they have the same base, then their exponents are the same. So we have 3x plus 2 equals 2x. Now what do we do?
So,
How?
can we subtract 2?
Subtract 2 from both sides? Sure.
Yeah, or yeah.
To get what?
3x equals 2x minus 2.
Good. Then what?
And then you can move the 2x to the left hand side.
Yes. By subtracting 2x to get what?
X minus equals negative 2.
X equals negative 2. Good. So x equals negative 2. And what should we do? Check it. Let's check it. Let's check it. So now let's check it. So far so good. Now let's check it. We want to see if whenever we substitute in negative 2 here, what we get on the left will also be what we get on the right when we substitute in negative 2 there. So I'll just check the left-hand side first. So now we're checking. So 4 raised to the 3 times negative 2 plus 2. That's equal to 4 raised to the what?
4 raised to the negative 4.
Negative 4. Good, because that's negative 6 plus 2. 4 raised to the negative 4 is what?
1. Wait. 1 over.
1 over what?
1 over 4 to the 4th.
1 over 4 to the 4th power. And what's 4 to the 4th? 4 to the 4th, not 4 times 4. 4 times 4 times 4 times 4. What's that? Y'all looking and shaking your heads and things? If you would like to use your calculator, feel free to do so. Huh.
256.
256. Excellent. So this is equal to what?
1 over 256.
Yes, good. 1 over 256. So now we need to check what?
To the left side. I mean the right side.
We need to check the right-hand side. So let's check the right-hand side to see if we also get what?
1 over 2.
Good. So let's check it. So 1/4 raised to the negative 2 times what? Negative 2 times what?
Negative 2.
Negative 2. Good. And then that's going to give us 1/4 raised to the what power? 4th power. Good. Now what?
I mean, well, no.
1 over 256. Good. Because that's the same thing as 1 to the 4th over 4 to the 4th. Right?
Mm-hmm.
So that's the same thing as 1 over 256. So does it check?
Yeah.
You got it. Those two are equal. So yes, that checks. What questions do you have? That's solving exponential functions. What questions do you have? What do you think? Compared to what you've been learning, is it challenging or is it as challenging?
It's gonna need some practice.
It's gonna need some practice?
Challenging. I would say it's easy to not know what you're doing.
Easy to not know what you're doing. What can help you know what you're doing?
Remembering the rules.
Remembering the rules? What are the rules?
If the bases are the same, the exponents equal each other.
If the bases are the same, the exponents should equal each other. So the goal is, if they're not given to you with the same base, you should do what?
Try to figure out how to get it to the same base.
Try to figure out how to get them with the same base. Okay? So it's going to be helpful to remember what two numbers have in common. That's going to be helpful. It's also going to be helpful to remember this rule here. This rule here, right? Because it helps you know how to rewrite a reciprocal with a negative exponent. Okay? So make sure you remember those properties. Okay? So now the applications. Now the applications, you need to know these. You will see them again. This is real world applications. Don't say, oh my God. You need to know them. Think about it. Whenever you get past here, whenever you get done with your degrees and you talking about let's make some money, let's do some investments, you may not even wait until you're done with your degrees to do that. You may be doing it now. Some people are in school investing money. Let's be real. So whenever you're in this type of situation where you invest in money, you need to know how to compute it. You have to. You need to know how to handle your money. Okay? Say it again.
So that's why you hire somebody.
Yeah, but you want to make sure you're not getting hustled, right? Your financial advisors, get them. That's why they exist. But you also want to make sure they're accurate with their numbers. Okay? All right, so let's get it. So, what is formula are we about to talk about? Compound interest formula. You need to know it. Compound interest formula. It says an investment of P dollars. What are we investing? P dollars. Compounded in times per year at an annual interest rate of R. Does everybody know what compounded means?
Put in, right?
Say it again.
Put into something? No, never mind.
You said put into something? Compounded means we're doing what?
Build it up.
We're building up. So we're running it. we're running it. That means we're compounding it, right? Compounded in times per year. That's how many times we run it. Okay? What is it in terms of?
Money. Oh.
Well, we're investing money, but we're compounding in times per
year.
Yearly. Okay? At an annual interest rate of what? R. It has a value after T years. T is in what? Years. T is time in years. So let's talk about it again. P is what?
Dollars.
And it's what we're doing. What is it? What does it mean?
Times per year.
No. P is in dollars, yes. But what is it? What does it represent? The investment. Good. P is our investment. N is what?
Times per year.
That we do what? Compound it. So it's the number of times we compound it per year. R is your what? Your interest rate. T is?
Years.
Time in years. Let's talk about it again. P is your what? Do we need to write this?
Yes.
Okay, you're going to keep remembering it because we're writing it. P is your what? Investment. Good. N is what?
It's compounded times per year.
Yes, the number of times you want me to use hashtag for number? Okay. Number of times compounded. Per year. R is your what? Interest rate. So whenever we're talking about an interest rate, if it's given in terms of a percentage, we have to do what? We have to change it to a decimal, right? We have to change it to a decimal. So make sure you're able to do that. So remember, percentage means you take your decimal place and move it to what side? Twice?
To the left.
Left? Good.
2 times to the left.
2 times to the left. Good. So, what's T?
Years.
Yep. Has a value after T years. Time in years. Okay, so let's look at an example. Jonna invests $10,000 in a savings account, earning 4.5% annual interest compounded quarterly. What is the value of her investment after 3.5 years? So, what do we know? So tell me what the variables. P is what?
10,000.
Good. P is 10,000. Good. Ashton, you were saying R. What is it? It's what? It's 4.5 what? Percent, which means in decimal form is what? .0045?
No, 0.045.
Say it again. I heard different things. I'm not confused. How am I confusing you? I didn't do anything. I just asked a question.
0.045.
Does everyone confirm or no?
Yes.
Yes, someone's still checking. Yes, you confirm?
I agree with her.
You agree with her? Because why?
Because we moved the decimal over 2 times.
Yeah, that's right. Because you take this decimal place and you move it 2 times to the left. So that's right. Okay, so that's important because this is what you're going to use in that formula, right? And then we know what? What's in?
Quarterly.
N is 4 because we said it's compounding what? Quarterly. If I said it's compounding semi-annually, what was in? 2, right? If it's compounded annually, what do I mean?
1.
N is 1. So be familiar with those words. And what else do we know?
The time.
T is 3.5. Good. Now, let's go back up because I need to tell you what the formula says. We talked about variables. So let's actually say what the compound interest formula is. It says an investment of P dollars compounded N times per year at an annual interest rate of R has a value after T years of A of T equals P times the quantity, 1 plus R over N, all of this in parentheses raised to the N times T. Okay? Are we all right? Okay. So if we want to find out what the investment was after a certain amount of time, given this information, this is the formula that we use. This is compound interest. That's the compound interest formula. You have to know it. Okay? So here we are going to say A of T we know is what?
3.5.
So A of 3.5 is equal to what?
10,000.
Good.
2,000.
Good. Parentheses 1 plus
0.045.
0.045. Good. Over 4
Over 4.
raised to the
4 times 3.5.
3.5. Good. Good. So now you can take your calculators and I'm going to ask you, what is the inside of the parentheses equal to? You have to make sure you know how to use your calculators, right? So I want to make sure. So tell me what the inside is going to be to 5 decimal places. How many decimal places? 5. Tell me what 1 plus 0.045 divided by 4 is going to be.
You do 5 to the left. Like,
Just 5 decimal places out to the right.
you said 5, right?
Yes, please.
Wait, what?
So so 5. So if you have 6 or 6 decimal places, you're gonna have to do what? You're gonna have to cut it to 5. So I'm gonna need you to round that last one.
I got 1.01125.
Talk a little louder. 1 point.
0.1125.
Does anyone confirm?
Yeah.
Yes? Okay, that's correct. We'll go with it. 10,000 times 1.01125 raised to the what power?
12.5. No, I live. That was funny.
Because you caught yourself because you were saying the 4 times 3, but remember left to right. So you get 4 times 3.5 is what? 14. Good.
I forgot to do the 2.
Yeah, the 0.5. The 0.5. But you remembered. So now, what is 1.01125 raised to the 14th times 10,000? Need a minute? Okay, I'll give you a minute. Let me know when you're ready. And I'll need someone else to confirm it. And what are we talking about? What's our unit? What are we talking about? Dollars, right? We're talking about money.
year, wait,
You do the, to the 5
what is the
years.
value of her investment after 3.5
Say what?
years?
Wait a minute. What was your question, Ashton?
Do we have to do the 5 years?
Do we have to do 5 decimal places here?
Oh, it's 2, right? Or
2 because we're talking about what?
that's a lot.
2 because we're talking about what? Money, right? We're talking about money. We're talking about money. So to make sure your calculation is accurate in terms of your money, we normally take what's inside 3 to 5 decimal places, and I'm just doing 5 for the sake of conversation. You round what? So if you have 3 decimal places, that last one should round that second one up if it's 5 or above, right? That's what I want to know. That's what I want to know too. What y'all get?
I got, wait.
Yo, you got me.
Bro, we got 11,695.
It's the sound.
Go ahead. It's what? What'd you get?
11,695.52.
I didn't get that.
Well, if
You-
you round
I
8,
got the same thing.
You got the same thing as Ashton, Kira? Anybody get? Marcus is shaking his head. He got the same thing as Ashton and Kira. So we have 3 confirming. So what did you do?
Hey, I missed
Tell me
the
what you
number.
did.
I missed the 5.
Oh, you missed this 5?
Yeah,
Okay, so try it again.
I did. And
Hey,
I got the same.
You got the same thing? So is everybody confirming now? All right, we're good. Excellent job.
you got rounded to 8, right?
You got it. Excellent job. Excellent. So, Jonna, after 3.5 years, what was the value of her investment?
She making big things.
11,695.2
$11,695.52
after 3.5 years.
after 3.5 years. So, Jonna, that's what? Because what? Tell me why.
The interest rate.
Then she put out 10,000, right?
That's right. So what? Go ahead. That's the type of rationale you need to have right now. Go ahead. Because she put in 10,000.
So she only made like
She only got 1,000 back.
That's absolutely correct. In 3.5 years. So that tells you that you would like what for your rate?
She needs one of the people
You
to
need a
hire.
higher,
You want a
higher
higher
interest rate.
you want a higher interest rate for your investment, right?
Yeah.
Wow.
So that was a great conclusion, right? You saw this and you were like, "Oh, that's a lot." And yes, $11,695.52 is a lot of money. But in terms of the investment, if you wanted to make more money, then you want the interest rate to be a little bit higher. You want a better interest rate, or you want it to be compounded more. It was only compounded quarterly, 4 times per year. But if it's compounded more, then you can make more money, right?
Yeah.
So let's do another concept.
Tired.
You tired? Or you said tight?
I said tired.
Oh, okay, got it.
I am tired.
No. Tight works.
No, type.
Mhm.
Type.
Tight. Oh, type, not tight.
No.
Type. Yeah. Okay, I'm with it now. I got it. Tight.
It's like
Type. Okay. All right. Okay. Okay. Got it. Okay. See, I caught on. It just explain it to me once. I got it. Okay. So, continuous compounding formula. Continuous compounding formula means we're always compounding, right? An investment of P dollars compounded continuously at an annual interest rate of R has a value after T years of A of T equals P times E raised to the RT. Some people remember that as PERT. Some people remember that as PERT, okay? We use this whenever we're compounding what? How are we? Continuously. That's important. Remember that. Continuous compounding means you use this formula. Are we okay? Compound interest means we use A equals P times the quantity. 1 plus R over N raised to the what?
NT.
NT power. Good. Now, P is your what? Your investment. R is your interest rate, and T is your
Like the year.
time in years. Okay, so let's take our Jonna example again. If Jonna invests $10,000 in her savings account, compounded continuously, earning 4.5% annual interest, what will be the value of her account in 3.5 years? What's our setup? P equals 10,000, yes.
R equals 4.5%.
R equals 4.5%, or good, or 0.045, good, that's what you want to use. And then go ahead. T equals 3.5, good. You need anything else?
You don't have to get the E?
No, because in your calculator, remember where, does everyone remember where to find E in your calculators? Open up your calculators. Oh, yes. So we walked around and everybody knows where to find your E button and how to raise it to a value, right?
Yeah.
So let's make sure we're on the same page. So now you have A of 3.5 equals what?
10,000. E. 0.0.
What do you want to do with that?
Multiply.
Raise it. Good. So raise it to the 0.045 times what?
0.0,
Times 3.5. It's all good. Raise it to that. 0.045 times 3.5. Now, your calculator will only do what you tell it. Okay? So one thing you may want to do if you have a basic calculator is multiply these first. Whenever you multiply these, what do you get?
0.1575.
Good. So this will be 10,000 E to the 0.1575, right? Okay. So now you should be able to enter this into your calculators. You get 10,000 times E raised to this. Remember that we're talking about money. So go ahead and find out what her investment was after 3.5 years if she compounded continuously.
Wait, how you put it in again?
Hmm?
How you put it in again?
How do you put it in there? Go ahead.
Did
Tell
you
me.
say it?
Yeah, that's, yes. So I'm answering your question by guiding you through it. What do you write first?
Well, you put 10,000
10,000.
in the calculator, right?
Yes. 10,000.
Then why hit second?
Second, and
Uh,
does your calculator take multiple steps at once or no? So let's look. Okay. All right. So some calculators you can enter everything at once. Sometimes you can't. Okay. And if you cannot, then, and you have a scientific calculator, you may have to enter your exponent first. So whenever I was being asked that question, sometimes, depends on the calculator, but for the question that was asked in the calculator that was being used, he first had to enter 0.1575 and then do the second button with the E raised to the X, and then you get a value and then multiply by 10,000. Okay? Now, what did you all get?
11,705.80.
Say it one more time. 11,000.
705.80.
Anyone confirm?
Yes.
That's only 100 more than mine.
Yes. So that is correct. So how much more?
Less than 100.
It is significantly less than 100. How much more did she make this time? Like $10 and what is the sum change? Let's be accurate.
Like,
Figure it out. Tell me.
28. It's 29.
Say what?
Can you make us do this complicated math and then you ask us 81 minus 50?
Because you need to be able to understand it and interpret it.
28 cents.
$10 and how much?
28.
$10.28 more?
No.
Was it? Is it 28 or what?
Notice that the
Should be what?
increase.
There you go.
$10.20 what?
Oh, what?
29. Yeah, because
I got around it.
Oh, because we did.
because you have 11,705.81 minus 11,695.52.
Oh, I didn't know we was subtracting. I didn't know we was subtracting.
Yes, that's how you figure out the difference here. So you would do that. Notice that this account earns $10.29 more than the quarterly compounded.
That's still bad though.
But she made more compounded account
She need to hire one of them financial advisors.
in example 3. Okay, there you go. So remember, you subtract the 11,695.52 from this amount to see the difference with compounding between compounding quarterly and compounding continuously, right? And if you want to see how much interest did she earn with her investment initially for example 4, you would do what? Subtract 10,000. Very good. You would take the 11,000. This is just extra information at this point. You would take the 11,705.81 and then you would subtract from that the 10,000 to see that she earned 1,705.81. What questions do you have? Okay, that's 7.1 and 7.2. Got 7.1 and 7.2. So a few things. I am. This is our last class. Yeah, it's been a pleasure teaching y'all this semester.
Everybody's here. I feel good.
Thank you for that. Yes,
Did you do the PDF for the review? Or I have to use my other class?
I did. Yes, I did. Open it up. Go ahead and check. Make sure you can open it. Someone confirmed at the beginning of class that they could open the PDFs.
Why Tuesday can't be our last class?
Say what?
Why next Tuesday?
Tuesday could be a last
But remember, you're going to see me anyway because you coming where?
to review.
That's what I'm saying. We have a review in class. That's a whole hour and 30.
No,
I'm gonna give you 2 hours from 3 to 5 though.
Okay, big. Okay.
You rather have
You
one?
right.
Oh, okay. I'm actually giving you 4 more hours because I'm giving you Monday from 3 to 5, Tuesday from.
3 to 5.
Y'all better show up if I'm showing up.
I got you. I'm myself.
So, okay, let's just do a recap.
I'm myself.
You have your final exam is when?
Next Thursday.
At what time?
8 to 10.
At 8 a.m.
From at 8 a.m. between 8 and 10. Where?
Here.
Here. Listen, y'all come to class on time because y'all have
How many questions?
about
How many
20.
times I didn't
About
come to
20.
class on time? I can count on one hand. How many times I didn't come to class on time, and I never was late beyond like 5 minutes or so.
You was late today, Beyonce.
I came in at 9:37.
Let's be on
Start
time.
at 5.
Let's be on time, everybody. Are y'all hearing me? Cause like y'all like rolling in here late at 9:30, and I'm telling you it's at what time?
8 o'clock in the
8 o'clock in the morning. Y'all need to come rolling in here at 7:55 or 7:50 if you know you got time issues.
Hey.
If you know you got time, if you know you got issues with time, I've been asking for a lot the whole time. I'm still gonna ask for a lot. Listen, cause I'm giving you a lot. So listen, 7:50 y'all should be rolling in here. So you're here and ready to start at 8 o'clock.
Oh, I have a good question.
I have a good answer. Say what?
Are you giving us a formula sheet?
Would you like me to create a formula sheet for you?
Yes.
I will create a formula sheet for you. I will create a formula sheet for you. You're welcome. You're welcome. I will create a formula sheet for you.
And
Now,
that quadratic formula for the EV up.
Y'all gonna be good. Y'all gonna be good. So listen, make sure you go through that sample final. Come in Monday with questions so everything can be reviewing. You want to give this time to marinate, ask questions. Remember, I'm going to extend homework assignments to Monday, the 29th, 11:59 p.m. Okay, I'm going to do that. When you come to the review sessions, I'm going to have your exams graded and ready to hand to you. We're going to be squared away with everything before the final exam.
All right.
Remember, your lowest exam grade will be replaced by what? Your final exam grade. Okay?
What if it's not high?
And if your final exam is not higher, which this is not going to be the case for anybody. If your final exam grade is not higher than any of the other exam grades, it won't replace any other exam grades. Okay?
And we start to do the quiz that's in Hawks.
You will have a quiz due, and I will put an announcement whenever that becomes available, and I will give you 24 hours to complete it.
Oh, the 7.1 and 7.2 are on Monday now.
Everything will be due Monday. 7.3 dismiss.
11:59.
11:59 p.m.
All right.
We good?
I still was trying to do that 6.4,
But you didn't come to my office hours and ask me questions about it.
No, I told
The
you
way I
I
was
was email it
live
to you.
for
I told you I was gonna email it to you, but like,
And I didn't get an email.
In the practice problems, it don't accumulate.
Why
when
am I
was
still
getting stuck
recording?
on.